Okay, 4.6, we're going to look at polynomial inequalities and also inequalities involving rational expressions. But we'll start first in this section with polynomial inequalities. And if you look at the little graph I got here, this is going to show us exactly what we need to do. Inequalities are going to be where p of x is greater than or equal, less than or equal to 0. So basically what we're doing here is trying to find those intervals on the x-axis where the polynomial is either above the axis or below the axis. So it all hinges around zeros. What you do is factor your polynomial, unless you're given factors. And then we're going to draw a number line. We're going to plot the zeros. We won't know what the curve is. We won't actually need it. We'll see in the example. We'll plot the zeros, and then as you can see, that creates intervals here, like this. Every time you have a root or a zero, you have an interval. So we have infinite intervals on the end and then these intermediate intervals here. Another thing to notice is this, and we looked at this earlier with multiplicity. When the multiplicity is odd, so you have a root to an odd power, then you're going through the root, and that means you have to move from negative to positive or from positive to negatives. So you're going to have a sign change here. However, as you can see here and here, when you have a multiplicity that is even, so this is where you get the same root, but it's used more than once, like x minus 2 squared. You would have a root of 2, but it's actually used twice. As long as this is even, you have no sign change. And that's going to be important. So even if I didn't know what the curve was doing here, if I know one value anywhere here, then I've got the whole thing. For example, let's say the curve isn't there, I just have a series of points, but I know, and we'll see how to do that in a minute, that the p of x has a negative value here, it's below the x-axis, then I know what all the other ones are, because that has an odd multiplicity, so I'm going to go from a minus to a plus. This has an odd multiplicity, so when I come out of this interval, I'm going to head through the root, so I'm going to go back to a minus. This one has an even multiplicity, so when I go through there, I'm going to bounce and come back down, so no sign change. Odd multiplicity changes signs because it has to go through it, so it's going to move from the bottom or below to above the x-axis, so that changes to a plus. And then finally here, when I leave this interval, I have an even multiplicity, so it's bouncing, so it's staying above the axis in this case, so it continues with a plus. So if I was trying to solve, say, p of x is greater than 0, that would be these areas here. I'll just put p, but it should be p of x. And then that would be from here on. And that would be that little interval. If it was p of x is less than 0, I would be looking at these intervals here. And then you have to be careful if it's less than or greater than, we're going to be using this kind of stuff. But it's possible we might have p of x is greater than or equal to 0. In that case, we would include the roots. So just remember that. Okay, so let's look at one. They're pretty easy to do. Let's try a simple one. This was in the homework section. The reason this one's a simpler problem is because it's already factored for you, so some of the work is done here. So step one would be to get the roots, which means factor the polynomial. That's done. Now we're ready to go to step two. Just draw the number line, plot the roots. I got a root at -6. I got a root at 1. Okay, and I got to remember that this one is going to be a bounce. Okay, so here's my two regions. That's at 1 there. If I don't know if it's plus or minus, if the function's positive or negative here, I need to find out so I can move from one region to the next. So that's simple. You can look at end behavior if you want. The book talks about that. But then you got to remember those rules and all that stuff. The easier way to do it is pick any one of the three intervals and just pick a test point in there, plug it in, and see if the function's positive or negative. So if you can, and generally you can, use 0. 0 is almost always available. So 0 is somewhere in here. We don't care where. I just want to look at p of x. I don't care about this stuff. So plug in 0. And I don't care what the answer is. I just want to know, is it positive or negative? Positive times a negative is a negative. So in this interval, the function is negative. That means when I go through this root, I'm going to change to positive. That I'm going to go from here above the x-axis. Now, when I go through this root, that's got a multiplicity of 2. The function's going to stay down here, so I'm going to stay negative. So in this case, p of x is less than or equal to, so I want to be a negative value or 0. So what I do is I go from here all the way out. It stays below or negative here. So what is the solution? -6 to infinity. And in this case, we're going to include -6. So there's one. Okay. Let's move on to the next example. This one's a little more interesting. Okay. All right, the first thing we notice is this doesn't look like px equals 0. No problem. Just move everything to one side and set it to 0. It doesn't matter if you move these here or these here. It's going to work the same. But since I'm interested in the standard order, I'm going to move these guys over here, and it'll just work out easier that way. So I would have x4. Then I'll minus 5x cubed from both sides. Then I'll add 20x to both sides. And I got my minus 16 here. And now That's the form we want. Now we're ready to go. Factor this, plot the roots or the zeros, and then look at the various intervals. And again, we'll need to pick a test point in one of the intervals to find out where the function actually is. Okay, so what can we do here? This won't group. It's 4 terms, that's great, but if you look at this, grouping's not going to work out. So we have various options. Probably one of the easiest is the 1 minus 1 test, so let's try that first. The 1 test, if you remember, add up the exponents, or the coefficients here. So I've got a 1 minus 5 plus 20 minus 16. If those add up to 0, and in this case they do, then that means 1 is a root. So I've already got one factor. I can divide that into here long division, or since it's linear, I'm going to go ahead and use synthetic division. That's a little bit easier. So put the root there, put your coefficients in, and remember to zero fill for those missing powers. So I got a 1, a minus 5. X squared's missing, so got to put a 0 there. Then x is 20. And finally the constant term, 16. Okay, bring down the first one. 1 times 1 is 1. Minus 5 plus 1 minus 4. Times 1 is minus 4. Add these up, that's minus 4. 1 times minus 4. 20 minus 4 is 16. 16 times 1. Okay, we expect that because we know that 1 is a root. So we have to have a 0 remainder. Okay, so what does that do here? Remember, we reduce the power by 1, so I have x cubed. So first I have this. Now what do I have now? X cubed minus 4x squared minus 4x plus 16. And all of that is going to be greater than 0. So we're starting to factor here. Let's take a look at this one. 4 terms. This one looks possible for grouping. So I've got my x minus 1 there. That's just going along for the ride. And here I can take out an x squared. And that leaves x minus 4. And here, remember, negative leading terms, so we want to factor out a negative. Factor out a minus 4. And that's going to leave x minus 4. Again, be careful here. A negative times a negative brings you back to a plus 16. All right, so our grouping worked. This is a common term. We can pull it out. So x minus 1 times x minus 4. Pull that common factor out, and that leaves x squared minus 4. And all that's greater than 0. All right, take a look at this. That's the difference of 2 squares. So that's going to be x plus 2 times x minus 2. So see how all these things are coming up that we've learned early on? They get used over and over again. So again, here we're using this rule. I forget when we learned it, but so this is the difference of 2 squares. That's how it factors. All right, so finally, we have x minus 1, x minus 4, x plus 2, x minus 2, That thing has to be greater than 0. All of these have a multiplicity of 1. That means the sign's going to change every time the curve goes through one of these roots. Okay, also, the degree was 4, and I have 4 different roots, so that makes sense. Okay, so we're ready to solve for the answer. Draw your line, pop in your roots. That's a negative root, so let me start with that one. Okay, and then we have a root of 1, 2, and 4. So 1, 2, 4. Probably should put little dots there where we're going to plot them. Okay, so here's the intervals where things are going to get different, possibly. Again, these are all a multiplicity of 1, so that means every time I go through one of these roots, I'm going to change sides on the x-axis. So there's going to be a sign change every time we go through these. But we don't know where to start. Is this positive, negative? How do I change the signs? Again, look for a test point. And right here, we have 0 in this interval. So just plug 0 into this equation here and see what we get. Well, 0 minus 1, that's a minus 1. 0 minus 4, that's a minus 4. 0 plus 2, that's a 2. And 0 minus 2, that's a minus 2. And again, I don't care what it equals. I just need to know if I'm above or below the axis. Is it positive or negative? Well, negative times a negative times a negative is a negative. So that means in this interval, the function is negative or below the x-axis. So since we know it changes every time we go through a root, it's going to go from a minus to a plus, from a plus to a minus, from a minus to a plus, from a minus to a plus. I need to be greater than 0. That means I got to be positive. So I'm going to be wanting that interval, this interval, and this interval. So all I got to do is write that out. Start at negative infinity. I'm going to go to minus 2. And it's smooth because we're not including 0 or the axis. Okay, then I'm going to union that with this interval. And again, we're going to start from 1 and go to 2. And then finally, we're going to couple that with this last interval, which starts at 4 but doesn't include 4 and goes to infinity. And that's it.